Hello everyone, welcome to another tutorial video on object-oriented programming in C++, especially target for beginners. And this tutorial video is all about uh, template programming with inheritance. So please check out the previous video on how to write a templated class, meaning user defined data type using template syntax and semantics as per C++ standards. And please check out the tutorial videos to talk about the to know properly the access specifiers like public, private and protected. And also there are tutorial videos which talks about inheritance and multiple inheritance as well. So this tutorial video is all about template programming with inheritance. So there is one clear distinction difference between standard class and template class. Is template class usually will not have excuse me, will not have the constructor and destructor, and almost all the code has to go into the one single header. So as far as the bigger project is concerned, take the header and the take the header and compile it, meaning go with a pre-compiled header concept and then link that header use that header which is compiled in library during compilation and use the DLL to run on the application on Windows, especially DLL or .sy in Linux and .dynamiclib on Mac OS X. So this tutorial video talks about template programming, which is class and single inheritance. So let's create a project. Template class, template inheritance. So this talk about single inheritance. Please follow the single inheritance concept so that you keep the project in a much more readable format. Otherwise multiple inheritance can create a lot of issues. That's why most modern languages actually avoid multiple inheritance to like Java and C#. Now the project is ready to go. So let's create only the class, because remember we are doing template programming, so we just need the header file. So what you can do is template parent. So this is the template object, let's say template object. So let's define the class. Template object, and we have access specifier called public. So this is the standard object-oriented programming construct syntax of the C++. So let's convert that to template. This type. Let's create the same like what we created last time: add, subtract, multiple, divide, with the return type. No, this time we are talking about inheritance. So what we can do, we create a protected variable of this type, and we store that value of the result in that variable. So please check out our previous tutorial videos to know about the access specifier called protected. So just a recap: the protected behaves as public for the inherited class, meaning the parent class is having variables as protected, including the method functions, meaning the methods, and the child class inherit the parent class. Then all the underneath the protected classifier behaves as public. But we create an instance of the parent class. For that, the instance variable of that parent class, all the code under the protected behaves as private, meaning it's not accessible. So let's create add this type var a this type. So remember to write all the code in the body of the header itself. So this is the distinct difference between standard object-oriented programming with respect to templated object-oriented programming in C++. So all the code has to come typically in the header, and in the final stages we have to actually go for compiled header things in C++, and then finally link the compile header to run to make the final executable to run. So this is the same like what we have the STL for C++ standard template library. So we have a result to store the result of the of the functions, which is having the data type called this type, which is the template type. So we'll define the what type we want when we create the instance of the class. So remember, this video is about single inheritance. So we'll actually create, I'll just come back and read the code. So we created a function. Return data type is this type. This type is type main, which is template. Inside the class called template object, now the class is template class, not the ordinary class, and it accepts this function accepts two variables of the data type this type, and it adds the variable. So we create three more functions for subtract, multiply, and divide. So this is sub, this is mult, and this is divide. So we'll change the mathematical operations accordingly. So we created four functions with the return type data type, and the result of the mathematical operations like add, subtract, multiply, divide is get stored in the result. So if you successively run meaning one after the you run the functions like add, subtract, multiply, divide, the result will be storing the value of the divide and not with add or subtract. So we actually need to access the result before we do the successive operations, because there is only one variable here which store the results. So the results get overwritten with the current value. So this is the parent. So let's say template parent. So this is our main class, the template class, the base class. Let's create another class which is the derived class, template child, and this is public. So this is the standard way of definition of the class. We convert that to template. So just to put this statement on top. So we have the template. Now we inherit the template parent of type this type. So this type is not properly defined yet. So this type actually defined by the template of the child class. So whatever the type we tell the child class to behave, like int, float, long, double, because we are doing mathematical operations, that type will be given to the parent class, which is also a template, and hence everything behaves the way the child class asks the parent to behave. So what we need in the public class is to access the result, which is of type this type, get result. So we don't pass on any arguments, so we need a void. So here another way I have to show how to implement this function outside the body of the class. So this is the outside the body of the class, because this is the ending of the class. So this is the outside the body of the class. Then we have to convert the function into a templated function, because this type has to be defined properly. Then we actually implement the return function, which is actually result. Let me check whether this template parent, which has the type protected, so this has to be, so somehow result is not coming. So what we can do if we have any issues like this, because there is always some issues between the standard way of defining the class and the standard way of defining the template. The simplest thing is to define uh, the body of the function inside the class. So how to do this? This is the simplest way of things, so that's to avoid all the confusion. To first we become conversant with template programming. So this is the standard way of doing things. So once we get conversant with the standard way of doing things, we can actually experiment the template. The templates programming is actually very much involved, so it's very easy very easy to create bugs in the compile time itself. There's a lot of rules variation from the standard class to the template class. So the simplest standard way to avoid any confusion is to put the entire body of the program inside the class and have the entire functionality what should be implemented in the one header file, no .cpp resource file. Then go for header compilation, compiled header, and then finally link it to the compiler to run the final application. This is the standard path that is generally most people use to generate templated libraries. So let's say whether this editor actually is able to pick the result. So result is available. So put the body inside the class itself so that you don't have any problems of specifying things. So one more thing. So let's say we want to define the class. So how to do it? Let's give it a try, because it can be slightly confusing. First convert the function into a templated class, and then you take the access meaning namespace. Then you have to put the type of the class here, because template child is the namespace, but we have converted the class into a template class. So we have to tell the what kind of type the template class is, which is actually this type. So this is the way to convert a standard function in the this is the way to convert a standard function into a templated function, because this function called getResult is inside the template child class, which is actually a templated one. So we have to put this extra angle brackets, meaning less than and greater than sign, and put that this type, because this type is the type name of the templated class, which is template class. So this is the way to convert the standard function called getResult into the associated templated function. So remember, there is another tutorial video in the few videos before. You can actually check out how to write templated functions. So this is the standard templated function. So you actually can see even the editor can actually show there is a result variable available for access, because this is the extra thing what we have to put in the body of the in the declaration of the function, because this will not be written in the standard way of writing the functions in the .cpp source file. So remember, put everything into the one header file. So now the header is complete, and we have 4 access functions available. We have inherited template the parent. The result is in the protected access specifier, so we actually inherited it, and we have a indirect access to the result, so we inherited it, and the get result is actually having access to the result indirectly, because we inherited the parent class in the child class, and the get result is in the namespace of child class. So this is the extra thing what we have to put for templated function in the with respect to the namespace. So because colon means a namespace, function name is get result, template and this angle brackets and with the word called this type is the namespace, and the colon actually tells is actually the namespace, and the return type of the function is this type. So the result is visible because we inherited template parent, and template parent is having the variable called result in the protected access specifier. So let's go to the main function. So and then we'll include the the header. So this is not a library header, so it is template object header. Then let's create two variable, and let's create template. So what is this template object h? So template child, we'll go for template child. We'll ask the template child to behave as int, and we created a int object successfully like this. Let's see everything is fine. Let's print out the results of the add function. Int object dot get result, because we have done the mathematical operation. So remember, in the parent class, as soon as the mathematical operation is done, it is stored in the variable called result with the type called this type. So we have to get the result after the mathematical operation is done, which is done by the template child class with the function called get result. So we have using the get result, we are getting the result. We have done, first let's do int object dot add. Dot get result. So there is some issue with the inheritance, because this is public. So we should get, we're only getting get result. So we have to check the access specifier is public. Somehow the functions are not visible in the object. Let's force it and see whether we get some errors. So we have there is some access. Let's see what the error we get. So this template is actually much difficult to implement rather than standard object-oriented programming. So it says declared here this type add is not accessible to template child. It's not accessible. We have declared the access specifier as public, and we are inheriting template in the template child and get result. So why this is not is it accessible in add? In add accessible. Oh, you forgot to give the access specifier called public. So just be careful when you're inheriting any class. We have to provide an access specifier for the parent class, like public, private, protected. Typically it is public because we want all the public methods and variables directly accessible in the derived class or the child class. So I forgot to put the public here, so I put it. So now it should be visible now. A comma. So now it should work. So we have done the mathematical operation, we are getting the results now. So this will have the add result. If you do int object dot sub a comma b and then put result, it will be having the sub result, meaning subtraction, not the add. So let's run the code. Let's see there. So it runs. So add equals 35. So don't forget to put the access specifier for the inherited class. So colon is the inheritance, then the access specifier, then the name of the parent class, and because this is we are doing a template, so we have to have the angle brackets and the type, which is actually this type of the type name, because it's a template class. So this is the implementation of the function which outside the body of the class. So you have to put this namespace before colon colon, which is the namespace of the class, which is template class of the template of this of the type called this type. That's why we have this type in the angle bracket. So this is extra as per the template programming is concerned, and this statement, meaning the top one, is actually the requirement of the template requirements as per the C++ programming language. So what we can do 4 operations. So we can do sub, we can do mult, we can do divide. So we can change this to divide. Okay, so everything should work fine. So we have all the integer operation, that's why we call the divide 0, because it's an integer operation. So what we, if we want to do float, we don't have to change the code, it's a template programming, so we don't have to do anything. So what we can do, we just copy paste. So I will just for do some petty printing, let me add something. So that is just we get some good indication in the printout what exactly we are doing there. So just copy paste, just be careful about what exactly copy and paste it. So we create a float object. Let's create the first float object, change the data type of the template class to float, and change all the class objects to float, and this is float type, and change all the get results to float. So let's run it. So we got the int results, division is 0 because it's an integer operation, and division is now float because we have the float operation. So we didn't change any code. We just created 2 templated class objects, and we told the templated class to behave as int first and behave as float next. So it's the same code running for int and float. So for the same thing you can do long and double. So it's the same process, just create a new object and change it to long or double if you want, and replace all these things, you get the same results. So this is the advantage of template programming, but the difference between the standard headers and the templated header is the entire put the entire body into the class, or properly convert the templated function with the proper namespace, otherwise you'll have compile time errors. So this namespace is very much important, and this statement on top of that is very important. This is the continuation statement. These two are just one line, but just to have a very good readability, we put enter, meaning we press the enter button on the keyboard. So this looks like 2 lines, but it is only 1 line. So this episode gives a very good overview of inheritance, because we are inheriting. So don't forget to put the access specifier when you are inheriting. Colon is the indication for the C++ compiler to inherit, and access specifier, then the class. This is the template class, so we have to provide a type which is known as type main type, this type, because it's a templated class. And this is the templated function of return type this type, and this is the namespace is very important, because if you miss this this thing, if you remove that angle bracket thing, you will get the compile time error. That is actually cribbing, there is a compile time. So this is very important. So everything is working fine now. So this is the standard way of doing inheritance in template class in the language called C++. I think I will end the tutorial here. So thanks for staying with me this long and watching this video till the very end. Please stay tuned for additional tutorial videos coming in this series. Thanks a lot. Bye.